So in part two of today's class, I would like to start the third phase in a software development process, requirement engineering process. So we talked about inception, we talked about illustration, followed by the analysis. We have talked about different illustration methodologies and techniques, and we also talked about different analysis modeling techniques. After we performed the analysis, it's very important now to specify the requirements. So we could write it in a formal document that later will be seen by all the stakeholders and particularly used by developers in the design phase. So I will talk about requirement specifications and I give you some guidelines about SRS, what can be seen in an SRS document and IEEE template for the SRS document. So requirement specification is a major step in the requirement engineering process because once requirements are elicited, modeled, and analyzed, it should be actually documented in clear, unambiguous terms. This could be done by a written requirement document that is critical in a way that the circulation of such document is possible among all the stakeholders. And those stakeholders could be the client, user groups, the development team, and even the testing team. What is an SRS document? SRS document, it helps in accurately describe each of the essential requirements, whether they are functional requirements, performance requirements, design constraints, quality attributes of the system, and even the software and the external interfaces. In the SRS, we have information about the scope and the boundaries of the system from the inception and the elicitation phase. Each requirement in the SRS must be described in such a way that is feasible and objectively verifiable by a prescribed method, which we did it before using the inspection, demonstration, or even analysis. The SRS is considered as a contract or agreement between contractors, suppliers, and customers, or the entire set of stakeholders. The SRS actually is elaborated based on the information from the elicitation notes and the analysis models that we were able to extract it from the analysis phase. SRS contains information to specify a requirement such that specifications are intended to a diverse audience. As I said, they could be customers and users that help in validation and validating the requirements. It could have information about system requirements that will be mainly addressed by the system analyst. Also, developers, programmers will use information in SRS to implement the system. Testers will actually check the requirements that have been met by looking into the SRS, which is the formal agreement between all of those stakeholders, in addition to the project manager that will measure and control the project by maintaining and observing the information into the SRS. There are different levels of details and even formality that must be met for each type of those audience or stakeholders. And there are many different templates for the requirement specification documents. The focus will be on the IEEE 830 template. To have a well-designed and well-written SRS will result in achieving 4 main goals. The first one, having a good, well-written SRS will provide feedback to the customer, a concise feedback to the customers. It will decompose the problem into component parts that can easily be traced. Also, it serves as an input to design specifications. And finally, it serves as a product validation and check for the entire notes and requirements elicited and analyzed and modeled through the inception, elicitation, and analysis phases. As I said, we will follow the IEEE 830 standards. The title of this standard is IEEE Recommended Practice of Software Requirement Specification. I have posted for you on the D2L template for the IEEE 830, so you could have a look at it and see what are the main contents of the IEEE 830, which will be discussed in more detail in today's lecture. In the IEEE 830, we have information about the content and the qualities of a good software requirement specification. Also, inside the IEEE 830, we have several sample SRS outlines. The main objectives of following such standards of the IEEE 830, because it helps the software customers to accurately describe what they wish to obtain. In addition, it helps software suppliers to understand exactly what the customer wants, and it helps those participants to not only develop a template, which is format in terms of the format and the content for the software requirement specification, but it has to be in their own organizations using their own language. Also, it helps in developing additional documents with high quality that could be guaranteed using a quality checklist that provide a well-written SRS at the end that considered as a writer handbook. The benefits of using the IEEE 830 standards template for SRS documentation, because it established the basis for agreement between the customers and the suppliers on what software product is all about. It reduced the development effort because it forced to consider requirements at the early stages, which reduces later the redesign, the recoding, and the retesting. The benefits of the IEEE standards SRS templates that later on will be used by the developers. It helps in provide a basic of understanding of those realistic estimate of the cost and schedules. Remember, we had to do feasibility analysis during the inception phase. All of these feasibility analysis and studies are also included in the SRS template document. The benefits of using the IEEE template, because it provides basis for validation and verification that can be easily traceable. It facilitates transfer of the software product to a new user or even new machines. It serves as the basis for enhancement requests. Different considerations that we have to stick with it as long as we will use the IEEE 830 standards for the SRS documentation. In particular, this the SRS using such a standard is divided into 5 sections. Section 4 of the IEEE 830 addresses how to produce a good SRS. So inside the template, you do have information about goals of the SRS, including functionality, interfaces, performance, qualities, and design constraints. We also have information about the environment of the SRS, which more or less related to where does it fit in the overall project hierarchy. We also have information about the characteristics of a good SRS that give a generalization of the characteristics of well-written good requirements to the document. We have information about the evolution of the SRS, which implies a change management process. We have prototyping that helps elicit software requirements and reach closure on the SRS. Finally, we have design and project requirements in the SRS that helps in identifying those external behavior and product, not only the design, but also the production process. All of this information, before even listing the details about the SRS, you can find it in section 4 of the IEEE 830. So the content of the SRS using the IEEE 830 template, we have introduction, and we have general description of the software product, specific requirements in very details, and also finally additional information that could be listed as appendices if necessarily. Let's now see what can we see in section 1 of the SRS. We have title, table of content, introduction. We have the purpose of the project, the scope of the project, all the definition, acronyms, abbreviations, references, overview. So the table of content describe purposes of the SRS, which actually describe um, what the intended audience will see. The introduction, identify the software product. It enumerates what the system will and will not do. It also describes the user classes and the benefits for each of those users. In addition, we define the vocabulary of the SRS, and you might add references as an appendix at the end. In addition, we list all the reference documents, including sources like use case model, problem statement, and even different experts in the field. You need in section 1 of the IEEE 130, you also have information about the content of the rest of the SRS, what comes next in chapter 2. It describes how the SRS is organized through the overview. In section 2 of the SRS, we have information about the business case, the operational concept of the system. We have information about how the proposed system fits into the business context. We have information about external interfaces, system, user, hardware, software communication. And we even have information about constraints related to memory, operational, or even site adoption. So in the first overall description, we have a summarization of the major functional capabilities that would include the use case diagrams and supporting narratives, such that actors and use cases. We also have DFDs if appropriate. In the product perspective and functionality, we have information about the technical skills and capability of each user class. This is in 2.3, the user characteristics. And in addition, for 2.4, we have information about constraints that will limit the developer's options, like what will limit the developer option at the next stage, including regularity policies, target platforms, maybe databases, network software protocols, developer standard requirements. So in section 3, after we have all the information in section 2, which is an overall description to describe the product perspective, product functionality, user characteristics and constraints, and any other assumptions that would be needed, we now going to section 3. Section 3 describe or specify requirements in more details. So specifying software requirements is sufficient detail to enable designers to design a system to satisfy those requirements. And even it helps tester to verify the requirements. State requirements that are externally perceivable by users, operators, or even any externally connected systems should be clearly stated in section 3. Requirements should include at minimum a description of every input into the system, every output from the system, and all the functions performed by the system in response to a given input or even to support an output. Requirements should have characteristics of high quality requirements. Requirements should be cross-referenced to their source. Requirements should be uniquely identifiable, and requirements should be organized to maximize readability. What can you see in the first part of section 3? You see information about input and outputs, like GIUs, if you have graphical user interface, or even what type of formats you may expect. If there is any functional information, this is 3.2, this is 3.1, which include the external information like the GIUs. It includes detailed specification of each use case, including this collaboration and other diagram that will be useful for such purpose. For databases requirement, you're looking for type of information used to identify data entities and their relationships. For design constraints, you're looking to standard compliances, and maybe later you will looking for accounting and auditing procedures. The main body of requirement organized in a variety of possible way that relates to architecture specification. You have also information about class diagrams. The state diagrams that we just described for today's class should also be included underneath it, the object-oriented models. So object-oriented model, quality attributes, design constraints, logical database requirements, performance requirements, functional requirements, and external interfaces, all of these information should be listed underneath the specific requirements. We were able to extract all of this information through the inception, illustration, and analysis phase. So it's very important to document them inside the SRS. So the IEEE 830 template in section 3 in particular, you should be aware that it could be actually organized in different ways based on different vision. It could be either based on models or user classes, or you could organize it based on the concept, based on the features, based on the inputs and different organizations. So it doesn't have to be necessarily in the same order that I just described. It could be organized in different ways based on the main criteria of listing or specifying your requirements. After you have all the information in the SRS, including the introduction, the overall description, and the specific requirements, you may add more appendices and indices if necessarily in your SRS. But at the end, there are main characteristics that your SRS must satisfy such that it is considered as a good SRS. An SRS should be correct such that every requirement given in the SRS is a requirement of the software. So you are looking for a correct requirement. You're not looking for a requirement that is not related to the software. Also, the SRS should be unambiguous, means that every requirement has exactly one interpretation. There is no ambiguity in defining your requirements. It should be complete, such that all the functional, performance, design, external interfaces requirements, and even the definition of the response of the software to all inputs are included. They are not missing anything. Consistent means we do have internal consistency between the entities in our system that are defined using the given requirement in the SRS and even the models that are built. Ranked importance in the SRS, you should have information about which requirements and components are essentials versus which one are actually desirable. The SRS should be verifiable before you proceed to the design phase, means all the requirements and models that have been elicited and a model must be verifiable. This could be guaranteed if and only if there is some finite cost-effective process with which the software would meet the requirements. The SRS must be modifiable, means the SRS must be structured to permit effective modifications. You should allow the SRS to be easily modifiable, but you should avoid any redundancy. The SRS must be traceable. That means the origin of each requirement should be given and should be clear. In building an SRS means that you have documented all the information needed for the design phase and all of the stakeholders to keep track of the software, the project, the scope of the project, the boundaries, and all the specification details about your requirements that later on will be used and even validated. So SRS, it could be written. You could draft it as an initial draft, and then you validate it multiple times until you do have a good or a complete final SRS at the end. So this is the end of today's class. And for next week, we will continue on the specification phase, and we're going to start requirement management phase.